Good morning, everyone. I'm Federica Cappelluti. I'm very happy to introduce Shalini Kurapati. Shalini is an expert on artificial intelligence, but also has a long expertise on data science, open science. And so talking with her, I thought that it would have been a nice point to understand some aspects of artificial intelligence linked to the idea of open source. What does it mean, open source, in this framework, and also how we can, let's say, link the concept of data curation. Also according to FAIR principles. I don't know if you are going to, let's say, talk about them. However, the principles of open science to artificial intelligence. In my view, it could be a sort of a win-to-win kind of work, even though I understand not everyone shares this kind of idea. And also, I guess Shalini will talk about a very rich landscape of artificial intelligence, much broader than what today, let's say, rumors are giving in general. So not only concentrated on general purpose generative AI, but more specific tools for researchers. So thank you very much to Shalini, and please go ahead.
Thank you very much, Federica. I'm just going to turn this transcript off so we will see the screen a bit better. So good morning, everyone. My name is Shalini Kurapati. I am a researcher. I used to be a researcher. I still am, but like not in a university, but I am a co-founder of a company called Clearbox AI. We are a data-centric AI company. I have a background in engineering, and then I moved into data science. And my let's say personal interest also is a lot about open science, privacy, ethics related to artificial intelligence as well. So today, given different, our audience today is quite diverse, and also the ones who would be listening in afterwards for the recording will also be diverse. So I kept today's speech relatively general, which can be used. And if we want something more specific, happy to discuss with you also afterwards. And I would also like to give credits to my colleague, Luca Gilli, who also helped me to prepare this presentation. So just to go ahead with what we're going to do, is to give you a general idea of artificial intelligence. Of course, there's a lot of buzz about it, but like, what's the perspective, especially from a researcher point of view? We talk a little bit about open AI models and proprietary AI models, how the landscape is as of it today. And a little bit also we'll be talking about data-centric AI, what that does mean, and also the concept of using smaller models called small language models or tiny language models, and how that fits with open science and licensing and ethical considerations. So it's kind of a bird's eye view of what open could mean. It's interesting also for you as researchers because it's an evolving definition of what open is. So it's also good that you would be able to both contribute and also use this current landscape. And just wanted to say, I'm happy to keep this quite interactive. So if you have any questions, please feel free to raise your hand, make this seminar yours as well. So I don't want to just give a monologue. Any questions or comments, please feel free to interrupt me, ask me, engage. I'll be very happy to do so. So just for a quick warm up, I would like to invite you to I would like to know a little bit of yourself instead of going around the table a more efficient way. Just use your phone or you can go to menti.com and use the code. I'm just going to switch screens for a moment, but you won't lose it because you will get the code again. Give me a second. I'm going to go here. So present. Just a little bit about your role and department, your background. You can use the code 49310201. Okay. Okay, so we have a couple of PhD students, researchers, experts in energy and telecommunications, a couple of AI experts as well, looks like, technologists, a library expert, researcher. Okay. All right, thank you. Let's move on to the next question. If you have to describe artificial intelligence in 3 words, what would they be? Just 3 words. Just to. It's difficult. Yes, but first 3 things that come to your mind if you have to describe AI, 3 words. You can also give adjectives or components or whatever you think about. Okay. Human brain imitation. Machine learning algorithms, progeny, fair enough. Efficiently automating activities, fantastic. Okay, I know that this is not the most easy question. Innovative. All right. Massive non-intelligent automation. I like that very much. It's pretty cool. All right, that's good. So I know that this was a difficult question to start with, and I'll give you a more easy one now. How familiar are you with artificial intelligence? Are you just like a beginner, or you're like using basic AI tools, or you're like maybe implementing it also in your research processes, not just for summarizing, but also like, optimizing stuff, or you're also like, leading AI projects? Okay, so we have a good mix. So that's good. So I did well with the speech preparation. So that's good. So okay, so we have a good mix. Good. And the next one would be coming to, if you want to describe open source AI, what would your definition be? Like in your perspective, forget about the 3 words. If you have to say open source AI, what does that come to your mind? What do you think when you know open data, open software? What is open source AI for you? Transparency, collaborative, open source code and training data set. Somebody's paying attention to the new definitions. Very good. Okay, that's very good. Let's wait a couple of seconds. Not just weights. You have good awareness. Okay. Ethical. Good. Interesting. You're helping me set up the presentation. Well, okay. Wait, one more answer, and then we go to the last question, which is also relatively easier. Reproducible and verifiable. Okay, verifiable. Very good. Excellent. The last one before we go is, can you name one open source AI model that you are aware of? Name one. So I will tell you why I asked this question in a bit. Yeah. Okay. Others. OpenAI. We're going to talk about that. Llama, yes, I was looking for Llama. Transformer, of course, it's that's kind of the basis of LLMs, of course, but I was looking more for a model. Okay, fair enough. Fair enough. You got the two ones, Llama and DeepSeek, and we're going to talk about the others as well and what does it actually mean. Okay, so let's begin. Share slideshow. Okay, we finished the Menti and then. So as we know that we are all here, we're talking about AI. Everybody talks about AI nowadays. Everything is AI generated, AI this, AI that. Obviously, there's lots of noise going around about this topic. And it is for a reason. Some of us might even get tired of this word. It's almost becoming a buzzword, but it does have some weight behind why it's becoming so important, because it's pretty much applicable to every field that we can think about. You can think of an application, you can use AI somehow. And it's providing massive opportunities and risks as well, like you rightfully said, whether dangerous, frightening, it's efficient, but frightening. So all of these are true. And most importantly, the reason why it's so important is because of the economic impact it will have, because this is just one of the many estimates that expecting that AI is going to generate trillions of dollars, and which is like, an order of magnitude higher than $1 billion. And it's going to have a great boost of economy. And we're also going to say that given this piece of cake, everybody wants it, the size of the cake, everybody wants a piece. They say it's going to improve our lives, or it's going to make us rich, whatever. So the demand driven by consumers. So basically in the private sector, we can say, okay, I see that it's going to make a lot of money to the economy. So we're going to invest in this and we're going to reap the benefits. How are we going to reap is another question. And then the same projections again, another company, they said that, in terms of a potential of increase of the global GDP, it's going to add trillions and trillions of dollars. And every other organization will tell you that it's going to be massively economically, beneficial. At the same time, you might be skeptical also as a researcher. Oh my God, okay, economical growth is good, but okay, what's up for research? So is it good for society? And yes, there's a lot of applications. There have been many examples, and even now it's working, especially in the field of clinical trials. AI is actually accelerating the process, not necessarily the design itself, but more the administrative processes, the in silico trials. There's a lot of acceleration aspects that's happening in terms of precision medicine. A lot of very good results have come. Definitely, we have to accept that. And especially if you think of the digitalization part or data analysis and even access to data, because one of the biggest challenges in sensitive data management is for you the speed to which you can access data sets in a very vast repository which has restrictions, and they have automated many of these processes, and much of the let's say, paperwork kind of thing has been automated. It's not necessarily the research itself. And as you might know, the last year, the Nobel Prize for chemistry actually went to a person who has nothing to do with chemistry, Denis Silis. He's the co-founder of DeepMind, and he AlphaFold for their protein unfolding won the Nobel Prize for chemistry. Interestingly enough, AlphaFold is nothing to do with generative AI, by the way. There are different types of AI, but it is an AI model, but not a generative AI model. But and everyday use also as researchers, you might be using it for a number of things. And some of you might be using in your research itself. You might be even working with models yourself, or using it for many other tasks. So this was research conducted in February 2025, 7,000 researchers of Nature across countries. Most of them are using it a lot for writing, summarizing, or maybe if you have a paper that's rejected, redoing it and maybe sending it, which is also perfectly fine. There's nothing wrong with it. Formatting, maybe for references, which used to be a pain to make everything. So there is a lot of kind of efficiency or, saving time, writing emails, changing the tone. And only very few are actually using it for data analysis at the moment. These are the most of the uses. Like, not all researchers are computer scientists. Not everybody will be using with AI models. So most of the use is being done for writing. And data collection and processing. And again, the reproducibility, it's going to be a bigger problem if you're using it for for data processing. So, and of course, we're also doing it for fun things. Even my child, who is 8, tries to do fun things with ChatGPT. I want to have a pig con. She likes unicorns and pigs. So it's also for creative purposes. Obviously, you all know this. We have done this. But again, coming back to the main definition of what is artificial intelligence, unfortunately, it sounds like a banal question, but it's not. There have not been agreements on what it means of artificial intelligence. The one definition that is being kind of accepted by majority is that of the OECD, what they have described it, and also Europe has agreed that this will be the definition of AI. That will also be used in the AI Act of Europe. So basically, it says it's a machine-based system. It can have explicit or implicit objectives. The explicit is okay, but the implicit objectives has had a lot of controversy. What does it mean to have an implicit objective? Because you're attributing something much higher than what it should be. And it's always based on the input it receives. Input is always data or some other instructions from us in the form of mostly data. And it generates outputs. Outputs could be predictions, it could be content, it could be recommendations or decisions. And these outputs can either influence virtual environments or physical environments. So they're also putting autonomous vehicles, robots into this equation. And of course, they say that different AI systems have different layers. And this is the definition that the European AI Act is going to look at. So so far they've been working, they have changed these definitions, I don't know, 10s and 15s times. This is the latest one that is kind of the OECD. And if you are interested in looking at the AI definitions and what that means, OECD is the place to look at. So, and in any sense, okay, I'm oversimplifying this. Obviously, this is not everything. Usually the key components for any artificial intelligence system is composed of data, code, and compute. Code, algorithm, we'll talk about the nuances, but these are the 3 components. So that makes it an interesting artifact also from a open science perspective, because all 3 are part of open science, because data, open data, code, research infrastructures, all of them come together. And that's what is needed to make AI work. And like we say that this is not necessarily a subset or anything, just to show that artificial intelligence right now, as of today, if you ask 9 out of 10 people will refer to generative AI. They will not be talking about machine learning or deep learning, even though the basis is that. They sometimes even call it, they call machine learning traditional AI now. I really feel very bad when they say that it's not traditional AI at all. So right now, when we are talking about it, it's 99% of the time. It's because I'm also a practitioner. I work with also industrial applications. And when we say that this doesn't need a generative AI, they say, oh, are you using the traditional AI? I was like, no, but anyhow. So yeah, nowadays AI is generative AI synonymously. It's unfortunate, but that's the reality. And usually the main difference, like you may know, I use the word traditional just because it's known. And they are much more specific. You have much more task-oriented. You can think of predictive maintenance or vision problems. And then you have general purpose AI, which are based on these large language models. One of you said transformers. They use transformers. And they use several tasks, not just one specific one. And they are trained on massive amounts of data. And right now, that's kind of, they are leading the current paradigm of AI. So basically, what are large language models? So large language models are capable of reading an input and producing an output. And this transformation of input and output is achieved through millions. Currently, I put billions because it started with millions. And now we have billions of parameters. And right now, the scaling laws are reaching their limit, but like even today, they believe that the higher the number of parameters, the better a model will perform. There are some discussions about that, but still, bigger is better is still the idea. So what usually happens for a large language model? The biggest chunk of work is during the pre-training of the base model. So basically, you start with the base model. You train it with as much data as possible, and most of the computing costs that you see about training an AI model is actually at the pre-training, when you take the base model and put every data that you can find and train it, and then you fine-tune it afterwards. And then you kind of, take the final model using the custom reward function. Then you do the reinforcement learning afterwards. But the foundation models that you said, Llama or DeepSeek, what we get is already in the first phase is already they have been pre-trained, and they give you part of it or a distilled part of it, not a whole model. And then you can take it and fine tune it. So the first part, you're not doing it because it's impossible for a single researcher to reach the level of a DeepSeek or something like that. What we will be using is more on the fine tuning part of the language models. And this computing costs of the foundational models, which are kind of let's say their treasures or their IP, they spend millions and millions of dollars on compute and taking data from questionable methods. So when you say ChatGPT, for example, it's actually a fine-tuned model on top of a GPT foundational model. So basically, what you are doing is, this is example from 2022. The GPT-3 version in 2022, and then you fine-tune it to make sure that the input and output is much more conversational. And even here, the human input is extremely important also to give more examples and stuff like that. For example, I don't know if you heard about it, but Google bought Reddit. You know Reddit, right? Reddit is this question and answer forum where you ask a lot of questions. So Reddit is licensing its data for $16 million per year just to do the fine tuning, because it's the perfect data set, because you have a question and an answer and you give it as an example to fine tuning. So that's the kind of fine tuning. But you have to remember that the cost, the environmental cost that we talk about, usually talks about the inference. Inference is like when you ask a model a question and it gives you an answer. That also costs money and energy, but the majority is actually happening already much before while pre-training this. So just for you to understand the difference. Right. So now we know just very little about what large language models are. Basically, they're just having billions and billions of parameters, and you give as much data as you want, and then they give you better quality output. And right now, there's a lot of discussion about open and proprietary models. And interestingly, even in the industry, not just research, I have to say the industry is investing a lot in research, in AI, and in collaboration. And a lot of cutting edge innovations are also happening in the industry side. I say industry, but even there is a very big divide between the players who are doing open and the players who are doing proprietary. So if you look at it, this is just a quick overview. The open models, the Llama that you talked about is actually championed by Meta, which is the parent company of Facebook. And then Alibaba is the Quen model of Alibaba. And they say that DeepSeek also has taken some of Quen and some of Llama and built on top of it. There's a lot of discussions about that. And then IBM is not really the leader in this. I would say in terms of open source models, I would say Meta is kind of open models. Let me remove the word source. In terms of more open models, we have Meta. Llama is one of the most downloaded open model there is. NVIDIA is also doing a lot of open models, much more on vision. And then we have private companies, especially Mistral. Mistral is a French startup. It does smaller models, but they're slow open models. And then Hugging Face, we'll talk about it also because it's hard to describe Hugging Face. It is a repository, but it also does a lot on AI. And then you have the closed models. So as of today, the most performing models are still proprietary, closed. So the various benchmarks, OpenAI is the one that's behind GPT. One of you said, which is an open source model. Some of you said OpenAI. Unfortunately, it's not anymore. The first GPTs were open, but now the current ones are completely proprietary, closed off. Anthropic is also another very high-performing proprietary company. And you must have heard about Claude. Claude is their interface. And then you also have Microsoft. Microsoft also does some open models, but they placed it in the closed because it has a big stake in OpenAI, and Google's Gemini models are all closed. Interestingly, both open and closed are getting a lot of investment, which is also interesting to note. Even open AI models are also being appreciated. And despite the high performance of OpenAI and Anthropic compared to let's say, open models, the gap is kind of closing. We see a lot of interest in the open model ecosystem. So I just want to tell you how this started, also this open versus proprietary, because this is not at all representative. I will be missing out a lot of things. I should be starting right from the YOLO models of computer vision, but I'm just going to, given the time and the discussion opportunities, just to give you, actually, AI started pretty much open. Like OpenAI was supposed to be OpenAI, like the models were supposed to be open. And if you actually look at it, their first model, GPT-1, which was released in 2018, was completely open. It was trained on 116 million parameters. You can actually download it and run it on your computer today. It's possible, and it was used on 5 gigabytes of data, which is laughable. And then it's completely open source and reproducible. And then we have moving to GPT-3 in 2022 that we talked about. And there we already went to billions of parameters. We started with 116 million parameters, and GPT-3 reached 175 billion parameters. And the training cost for GPT-1 might be just a few euros, maybe tens of euros. But then GPT-3 already, remember the pre-training, where the first stage we trained the base model with as much data as possible in Qt, that already increased to $4.5 million. So a normal group or a university itself cannot even start with training their own GPT-3. And then Here, they released the documentation, but no code was released and no weights were released. So they still made it somewhat open, but they closed off the weights and the code. And then this was GPT-4, which we don't know anything, and even GPT-4.5, nothing at all. There's a lot of speculation about how much money was spent, how much energy was spent, but we can only guess at the moment. There are also some researchers who are actively working on how much these models cost, and they can only come up with estimates. There are no official figures about how much, and they at least estimate a lot of money. We're going to see how much. So the better the models were performing, we saw kind of closing off of the information saying that it's not sustainable. Of course, investors came in, so it's more of a commercial, despite the fact that OpenAI started as a non-profit open organization. So and now coming to open models. So you talked about DeepSeek and Llama. Yes, they are the most commonly used open models. However, I would like to point out, even before this is something very important for also you to know, that Eleuther AI is one of the first open source initiatives. It's actually a research group with a bunch of researchers. Their mission was to kind of reproduce GPT-3 with the amount of with the information they had. So basically, they pulled in resources and they kind of reproduced GPT-3. And then they released with an Apache 2.0 license, which is very permissive compared to the data license. So this is very much an open source AI model. So they're still doing very good work. And if you're interested, please support their work. They're doing an excellent job. And then however, the most popular open model is from Meta. Even, I don't know, if you're using WhatsApp, a couple of weeks ago, you must have gotten some Meta. I don't need it, but we get it. And it's based on some form of Llama models. We don't know exactly, but however, I have to say, despite the reservations, I am not a fan of Meta at all. But compared to the other companies, the fact that they have kickstarted the Llama models was a very big step for openness in AI, because they decided to go open. I think it was also more of a strategic choice, saying that, okay, we cannot compete on the performance right now, let's go open. And they are much more popular. You see a lot more people using their models, and probably they're also getting a lot more data using also their own services. However, DeepSeek couldn't have been possible without Llama, for instance. There has been also many studies that said that DeepSeek was built on top of Llama infrastructure. So it was kind of very important. And also Meta is the one that released PyTorch. PyTorch is also very important, let's say, in the ecosystem of AI. So I have to say that at least they have opened up the models. It does have the Llama license is interesting, because if you look at it, if you are not Google, if you're not Amazon, the license is okay. It's relatively permissive, but it's written in a way that Google or Microsoft or Amazon cannot use it, kind of thing. That's pretty much the Llama license in a couple of sentences. It's definitely useful as a starting point, but I wouldn't call it an open source AI. It is an open model. It's not a fully open source model. And it has some other issues that we will be talking about. So that's Llama for you. And there's a family of Llama models. We'll also see very quickly where do you find these models and how do you deal with them. So and then recently let's say last year, especially, DeepSeek kind of created this whole sensation in the news, saying that it's the end of proprietary software, etc. And it did perform really well. They claim that they managed to do the pre-training with a fraction of the cost of the bigger models. Some of it is true, some of it is debatable. However, despite that, DeepSeek is still a very popular open model. A lot of people are using it either on the cloud or on their computers. And it's a very good reasoning model because and it's also impressive that it was as good as GPT-4, which was completely proprietary. So it really changed a lot. And even there's a lot of fear also in the proprietary companies because Google has this famous statement saying that we have no moat. Like open source is really killing, they call it open source. Open models are killing our competitive advantage. We don't have a moat. And interestingly, the only moat every company has is data, because whoever has the proprietary data is going to have a better model as of today. So its data is the one that's the moat. And then we have so many stories about Stability AI, releasing another open source model. And then Llama has become extremely popular among developers. And also DeepSeek, for example, was hailed as the Sputnik moment of China. It's like it's come back, and they're really closing the gap with the US. It's a balance of power, and because of the claim that DeepSeek was able to train their models with a fraction of the GPUs. NVIDIA was the GPU provider. Their stock really plummeted last year. So open source is really a big force in the AI system. Forgive me if I keep using the word open source, even though I don't mean open source, because it's different. It's hard to. So one of the points. So one of you said there are too many models out there. There is, of course, you see Llama, you see DeepSeek. But if you want to know other models, there are many places. But the most popular and the most used, let's say, a repository of models is called Hugging Face. It's a French startup. It's something like a GitHub for models, let's say. That's oversimplifying it. But like just to give you a quick example of how this looks like, you just can go to Hugging Face and you create an account. I'm not logging in at the moment. But if you look at the models, you have models, data stacks and spaces. If you look at models, you see the number of models here. You have more than 1.7 million models available. They are open. Either they are foundation models, or they are variations of it, or they are fine-tuned models. There are so many of them. And for you to just quickly navigate through this, it really depends on what you want to do. Do you want to do do you want to do computer vision, or you want to do some kind of a text classification or text to speech? Let's just look for text to speech. You say you want to build something text to speech model, and then you can choose. Especially for text to speech, it's important to specify the language. You say, okay, I need a language that is, Italian, let's say. I want the Italian one, text to speech. And then you can choose the licenses. You can choose a permissive license. Usually MIT is the most permissive. Or you just say, okay, I want an MIT license, and then your models, the number of models that you can actually use become extremely low. And then how you choose it, you can either choose it whether it's the most trending or it's the most downloaded. If you say it's the most downloaded, it looks like this Suno is the most downloaded, and then you can see. And the model card is something that will tell you about the model. It's kind of a README file for your open source model. So you can like kind of, there's an example in Colab. They tell you all the installation instructions. And you can also see, based on the files, how much memory you would need. And then you can, usually most of these models on Hugging Face should run on a computer. Depends. You can look at the your requirements, and then there's also the hardware requirements in the model card. So explore Hugging Face for more open models. This is like the go-to place. Every big company or DeepSeek or Llama, you puts all their models there. As well. So it's a one-stop shop for all your open source models, and they are kind of a community which are very much on open source, open model AI. So Hugging Face is definitely, maybe some of you already know it, but if you don't, please explore it further. So now the question again, since I've been using the word open source, let's talk about how open are these open models. So that's kind of an important thing. And what does open mean? We also need to discuss what does open source mean. So a note about licenses. So when we talk about even open licenses, the organization or a community, or if you want to say a group that is respected by the open source community is called open source initiative. And they are the ones who come together and set down rules saying that this is open source and this is not. And you have to remember that these are the veterans open source software people, where they believe that it has to be completely permissive. There should be no restrictions at all. So in terms of free to use, remix, I know as long as you credit them, though attribution is not an issue, but like the freedom to reuse software is extremely, it's a core principle for them. So they do have a strict review process even for software. So it's not just for AI, even for open source software, they do assess if an open source software license can be called as an open source software license. And if you look at their, let's say, licenses, these are the approved licenses that they, you can look at, the Apache licenses, there's a CERN license, the CMU one. It's a very good, let's say, resource for you to check out if you're, if even the software license that you're using is really open source or not. And then next question comes to about these open source initiative is also beginning to define what open source AI means. The definition is still under community review. So it's not official yet. And even if it's official, it depends on who is going to adopt it. That's another question. And if you look at the endorsements in a second, you can see that Mozilla Foundation, Software Heritage, you have the government of France, they're all supporting this definition of open source AI. But you don't see big other companies or organizations that are. So if you want to endorse this definition, if you believe in this, you can also endorse it as an individual or as an organization. So that's up to also how the community wants to view open, because there are a lot of issues with open source AI also for ethical reasons. We're going to talk about that. But according to this open source initiative, the AI definition means that it can be used for any purpose without permission, and you should be able to inspect the system, transparency. You should be able to have the capability to modify the system and share it as you like, given the conditions of the license. And this is the vision of the open source initiative. That's what many researchers or community members believe in. And in addition to having the permission to do whatever you want with it, you need to also disclose all the data that you've used for your pre-training as well, not just your. And even if it's unshareable and proprietary, you should at least give the sources, which data you used for it. And you should describe the sources, the scope, the labeling, the filtering, the access, and again, as close as possible, as open as possible, as close as necessary. But even though you don't, release the data itself, you should at least release the information about the data. And code should be available. And the weights, one of you talked about the weights or the parameters and through the different training checkpoints, because it's not just a static model. And then they should also provide the intermediate and the final state of the model. So, and if they do that, they are considered fully open source AI according to the open source initiative. So for example, they have done a lot of analysis of the models. Remember, I showed you about the Eliator AI, the group of researchers who are trying to reproduce GPT. Their model, for example, is compliant under open source initiative. and even T5 from Google. By the way, Google also has a few open source models. They are also compliant. And the potentially compliant ones are Bloom, which is also part of Hugging Face, and then StarCoder and Falcon. They could be, but they have to make minor adjustments. Llama, free models. Free models are actually very good. Unfortunately, they're not open source compliant, but they are really good models, very small ones, very, very high performing ones. And Mixtral from Mistral, all of them, the biggest challenge for them is they don't provide their training sources, especially. Code is less of an issue, but they have restrictive licensing terms, and they don't do it as open as the others. So the problem with open source, that's also something we need to discuss and critically think, is that if you look at it, they say that you should be able to use it for any purpose. And that is a bit complicated with artificial intelligence. If you say that you can use it for any purpose, you don't have control of what they might do with your data or your software. So we should also be thinking outside the permissiveness of the license, which was the original tenet of open source. Like, it needs to be as permissive. You don't need to ask any permission, or there shouldn't be any restriction. I fully respect that aspect of open source, but when we talk about AI, which is very powerful and highly impactful, this is also something we need to be cognizant about, like how permissive should an open source license be, because there are a number of issues that we should be looking at before talking about open source licensing. We know that especially the data labeling that happens for such models. So how are these models generated? The transparency issues that we talked about. There's a lot of human involvement in the whole labeling or the reinforcement learning, where you have to kind of correct the model if it's behaving bad. And then those are done by human data farms with very poor conditions. And then you also have a large amount of IP issues. Because the data of the most high-performing models, including DeepSeek, including Llama, including both the open and the closed models, we don't know where these models got their data from. They have massive IP issues. There's a big aspect of, let's say, stealing data, which is, again, a big conflict of philosophies for open source science community, where in open science, we want everything to be open. But here, we are having IP issues for the training. Is it fair use? There's a lot of discussions around this. And then you also have this particular safety issues, like, for instance, you can say that, I want to fix an electricity. If you say it's extremely permissive, maybe you can use it to build a bomb. But if it's, let's say, if you have a little bit more fine tuning or restrictions, you could also make it, add the guardrails, for example, and then say what ChatGPT has done is, like, it will not tell you that if you want to build a bomb, it will say, no, I cannot tell you. But if I want to repair an electrical socket, it says it's still dangerous, but I'll try to tell you. So this type of guardrails are something we should also be thinking about when we release the models. And then another big issue that we should be thinking about also the models is that these models are getting bigger and bigger. So this is a picture of the CTO of Microsoft. He was giving a talk last year about the sizes of the models. And he was saying that if GPT-3 was a shark, GPT-4 is an orca, and the next one would be a blue whale. So if you think of it's like, I don't know, hundreds of billions of parameters big. That's a speculation of how big the next model is going to be. And that also means that the training costs are going to massively increase. And we're going to have, like, this is an estimate of the Gemini model. This is from 2023, that it took the pre-training, it's about $190 million for pre-training one model. And you should think about, like, and it's in that order of magnitude for all these models, for every model. And so this massive amounts of capital that's going into this industry. And then we also know that this kind of making it big is we are seeing that they're not making as much money as they think. they're actually losing money. And the ROI, they keep promising it, but like they're losing, they're getting a lot of capital injection. Both Google is burning money as well to compete. So it's a very capital intensive field, and it's hard for this breakout of, it would be very difficult for the fully open model to survive. And in addition to the massive amounts of money that's being spent, the energy costs are also extremely insane. And all these are also estimates. We don't have correct declarations from them. So even compared to GPT-3 and GPT-4, you can see the amount that's really like exponentially rising. And imagine for the next model how big the data costs are going to be. So the other aspect is that we've seen that Google and Microsoft are actually buying nuclear reactors to power their data centers. So the energy consumption is really being directed to these massive big models, and that's also a point of concern for everybody about the fact that energy is such an important resource, and we are diverting it all for these very big models. So in addition to the energy issues, we also have water usage, because unfortunately, they cannot use seawater, which they thought they could for cooling the data centers. They use drinkable water because otherwise the pipes will rust. So it's, in addition to the massive energy cost, we're also using precious water to make sure that these massive models are able to work. So inference is really really when you ask a question and you get an answer. And depends on which part of the world you are. Like even if you ask for for 30 clean inferences, you're using 500 ml of clean drinking water. So yeah, if you for a few of your email tweaks, you're using quite some water. So that's the issue with the large models, and also the other big concern that we have is the fact that they're very monochromatic in a lot of things. That many of them are very English-centric. So of course we do have some multilingual models that are coming up, but most of them are trained with English corpus. So the performance is very varied, and even if you ask a question, apparently the process, if you look at the processing, you see that it's first translating it in English and then back to the language, which could cause some cultural issues as well. So now, because open source AI doesn't really talk about ethics, it only says that you need to be permissive, you need to make sure that you disclose it. It talks about permissiveness and transparency, very little about responsibility, about the ethical part of it. that's why we need to think both in terms of open source, but also responsible licensing, not just completely open source, because right now we do have this very transition stage of what open source AI means, but it's in a good position. The odds are in our favor. The fact that we are able to even access such a technology is very promising, instead of it being completely closed doors. Like we have a model that's openly available, that's as good as GPT-4, that took 200 million to train, is a good step forward. It's not the perfect one, it's a good step forward. And what we could do with this and make it better is something we have to be thinking about. So again, coming back to the fact that AI is a part of data, code, and compute. Right now, the whole point of bigger is always better is something we should be going a step backward and trying to say that bigger is not always better, and we should also be trying to understand all these environmental impacts and the costs, and try to focus a bit more. You don't have to have general purpose models for everything, and there is a new idea of also going into a smaller model, small language models, and sometimes even tiny language models. So usually small language models, they still have a few billion parameters, not 200 billion, but like 7 or 8 billion, but they can still be run on a very powerful computer, and that you don't need massive infrastructures. So there is also a very big ecosystem of small language models. So these are they are kind of distilled from these very large models, and you can use them for specific purposes. You have a Llama distilled models. You have Meta has many of them, and you also have Qwen. You have DeepSeek, small ones. And the most good examples that are heavily used are Llama, more for edge devices. Qwen is from Alibaba, and it's used for more multilingual applications. DeepSeek is distilled from Qwen 2.5, which is from Alibaba. And then the fee models are actually very good. They're multimodal, and they work really well, as good as GPT-4 for as many tasks. And the Gemma 3 model is, again, DeepMind, and it's multilingual and multimodal. And the others, which are a little bit bigger, they have 7 billion, because until 4 billion, we call it small. The tiny ones are they're more on the million side, but these models can be accessed and used by everyone. Again, you can find all of them on Hugging Face and download it and run it on your computer. And the most important benefits that we see, obviously, of these smaller language models is that you will be having low compute requirements if you want to fine tune it. You can do it on your laptops, on your edge devices. You have faster inference. You don't have to wait for a really long time. And if you have privacy concerns, if you're using sensitive data, you never put anything online. It's cheaper deployment, and if you want to do something very domain specific in your research, it's very good. But we do have some limitations. If you have fewer data sets, it might struggle with some complex tasks. But if you have good data sets in your domain, you can fine tune a very good small language model for your task with the fraction of the compute and the fraction of the cost. And an example for this was the University of Berkeley. They actually trained a small language model called Koala, and they spent $100. And it was as good as GPT-4 for a task that they had trained. It's actually for understanding it was for text generation, but still they measured human performance, and they could not tell the difference between ChatGPT and Koala. So it's also an innovative way to use the open models available for your particular task. And the most important thing we should be also looking at in terms of using small language models is to have a bit of a shift from a model-centric view to a data-centric view, in the sense that so far, the bigger the better is being the perspective. I'll have more. I don't care about the data. I'm just going to keep making my model, increasing the parameters, and I'm going to do okay. But now there's a bit of a shift towards a data-centric AI, where you kind of focus a lot more on data acquisition, cleaning, auditing, generation, and also on the FAIR principles, if you may. To make sure that the training data is of high quality, can be traceable, reproducible, accessible, and then you improve the model based on the improved training data set. And that's where the small language models also become the heroes, because if you have a very high fine-tuning data set as well, you'll be better off with a much smaller model with a fraction of the compute. So there have been many good results. Example, the fee models of Microsoft, they have actually been trained on very highly curated even data sets, including synthetic data sets. And they have outperformed GPT-4 on many tasks. And again, they're much smaller. And also DeepSeek used a lot of even synthetic data to improve its results. So, and the other important thing we need to think about is right from the data analysis in terms of improving environmental impact and resource allocation. Data-centric AI is really a way to keep your model static and improve the data. And it's good for the environment. It's cheaper, and it's also more efficient. And last thing before I conclude, and then we open to question, is the fact that we talked about efficiency of models. We talked about how open the models could be. The other difficult issues we still have to deal before we say it's fully open source. is the issue of how do we manage these two things. And the main thing when we talk about open science or open source, we want it to be open, we want it to be transparent, responsible, publicly available, ethical, free, and it might be very difficult to achieve all of it with AI, given the way it's built. However, there are some initiatives where they are kind of mixing this open source with few other things, like adding a new type of licenses. It's called responsible AI licenses. So basically what these licenses say is that you're not allowed to use data, my model for everything. You have to agree that you'll not use it for war, you'll not use it for training, building a bomb, or so you basically reduce the permissiveness, but add it from an ethical perspective. So there are some examples of these licenses. It was also presented in the fact, and it's gaining some traction. So instead of making it fully open source, you make your license a responsible AI license. So and there's also a little flow chart which will tell you where you can license all of it or some of it. You say, I license only for my data, or only for applications, or only my models I'm going to license, or my source code. And you can also license all of it or a few of it, citing your ethical reasons. And there is like a very nice flowchart where if you want to release your fine-tuned model, let's say on Hugging Face or something like that, you can always choose a rail license, and you can just put a suffix saying that I'm open rail D, or you can also close it and still give a license. And you can say whether you're going to license your data or apps or models or your source code. So you can also critically think how open you want to be in terms of ethics as well. And the other, you can really go to licenses.ai and you can see and the open, you can generate a license. So there's actually a very nice example as well, how to generate these licenses. So so you can just say I'm a test project, and then you can agree, and you can create a license whether you want to only do it for research, that you only want to give this license for research only. And then even there, it says you should not use it for weaponry or warfare, things like that. Sorry. So, this is not probably approved by the open source initiative, but still it's a responsible AI license because you're deciding how to give your open source license. It's still a way to do open ethically. Sorry about my throat. And another important thing for open source AI is the regulation of it. We soon have AI Act, which will be regulating the AI systems. It gave a lot of concessions for open source AI, but that doesn't mean that you shouldn't follow it. Because if you use open source AI for any other applications outside research, you have to comply with it. But and especially for high-risk applications, which is general purpose AI models also fall under. There's a lot of transparency requirements. So basically, what an open source should mean for you could be transparent and ethical. Might not be fully permissive, but if it's transparent and ethical, it could still fall under open source. But of course, the definition might not be approved by OSAD, but still from an open science perspective, it could still be acceptable. And then you also have, for high-risk AI systems, anyway, the degree of transparency is extremely important. You have to show that you have tested the model enough, where are the data sources coming from, make sure that they are robust, and all these safety procedures become exceedingly important if you want to comply with the regulation. And here again, data becomes extremely important because one of the biggest ways to test the robustness is to use high-quality testing and validation data and prove that what data you've used to make sure that the model is robust. And in terms of transparency, it's not all lost. Even the open or closed systems, whether I think my vision also would be, instead of debating about how open source the whole open source AI is, we should really focus on how transparent these systems are for us to validate, test, and check for their safety. And there is some good news, because the pressure on because of the open source open model evolution, we see that the transparency scores of many of both the closed and open models are increasing. So Stanford does this study every couple of years, and they've compared that since 2023 to 2024, even the closed models of Anthropic and OpenAI seem to be improving on the transparency side. So they are providing some more information. Not very much, but at least it's going in the right direction. There are a lot more benchmarks to study. And in terms of transparency, what do they mean? They mean what was the data used, what was the compute, what are the model access capabilities, risks, mitigation, usage policy, impact. So basically, it's very much a combination of transparency and ethics. And these are the transparency index for the models. And I think even researchers should be aiming to be looking at these things. Are they able to, provide a model card or something that tells all of these things, like a README file that you do for a software? Are you able to do this? I think that would be the first big step in making your models responsibly open. And just to, the relationship with open science and AI is very, very close, because if you look at the definition of open science, it's really to make sure that every scientific input, irrespective of the discipline, it's openly available, it's accessible and reusable to everybody, and the knowledge creation is open to everybody. And then this includes all the disciplines, and also it's extended to scientific knowledge, infrastructures, science communication, and engagement of social systems. And when we talk about scientific knowledge, it's actually publications. We already know about publications. We talked about open data. We talked about open software, open code, and open infrastructures. And somehow AI encompasses all of it, because it does need data, it does need publications, it does need infrastructure and code. And I think for me, AI is kind of it encompasses all the components of open science that is required to function. And the biggest challenge in the open source AI is also to make it open source and responsible AI. That will become a big challenge also for the open source community. So again, talking about the fact that we should focus on the three elements where we can be, open, robust, and safe in terms of data, in terms of our algorithms, and our computational costs. So having said this, I still believe that open source is the way forward for AI, but how we define it is still up to discussion. We should not just be focusing on open, we should also be focusing on responsible, and sometimes they might not really fit in terms of permissiveness. And I fully believe that transparency should be the baseline for any discussion going forward. And just to conclude, what I want to say is it's open source AI in whatever form is rapidly advancing. High quality data is even more important today. And then we should be focusing more on the small language models and not the general purpose models, using the available resources that are at our disposition. And we need to be also focusing on ethical aspects when we share our models. And we should be embracing data-centric AI and open science practices, especially on transparency, not only to advance your own research, so you can be testing these models on a very small infrastructure, advancing your research, but also science and society. So thank you very much. I hope I covered too many things in an hour, but I hope it was useful. Thank you very much.
Okay, I can start maybe. Okay, one general comment is thank you, because there's a, let's say, quite wide overview. At least I think it's useful to understand that considering the ChatGPT as a kind of Kleenex of AI is quite inaccurate. That's good. Now, I have a provocative question to start with. In this discussion about open source AI and responsibility, It is somehow, it seems to me, that people are, how to say, implying that instead proprietary AI would be responsible by default, which I don't absolutely think is a good guess. I mean, thinking that companies are responsible or, as you were saying, ethical. So can you comment a bit on that?
No, absolutely. I think this is also kind of I think a bit of a distraction also for the open community of saying that open models can be unsafe. There is some element of truth to it that if you don't, if you let people use the AI for whatever purposes, that is an issue with open source. You cannot really control because it's a permissive license and you don't know what happens. And that's exactly why we need responsible AI licenses. You can still keep it open and say that I don't want you to use it for military purposes. I don't agree for you to use it for. So that's the issue I have with the open source initiative definition that says that they can be used without any restrictions. I think without any restrictions should not be the norm for open source AI, just because of the potential that it has on impact. So I still think it should be open. I don't think proprietary companies are ethical or they are safer. But if we want to do open source AI safer, we should be at least educating people of how to make it safer and open as well. That would be my perspective.
I have a question, curiosity maybe. About the example, one of the previous example about building a bomb. My curiosity is that the safeguard is in the model itself or in the system that is using the model. So is there a way to avoid the complete issue of knowing how to build the bomb or?
Yeah, of course. So the question is that the issue of building a bomb. So how would we know that there is the if I understood it correctly, how do we prevent this happening? Or what is the process that we can use to prevent, or is it in the training data? Because just to answer your question, in the training data, there could be instructions to build a bomb, and the model is able to give that response. But then there's actually there's actually even a system prompt that you can introduce to say that do not answer if they ask you to build a bomb. And this is where the humans come. I think a couple of days ago, there was even a leaked system prompt of Anthropic, where they talked about the fact that what is your opinion about Donald Trump? They actually were instructing the model to say a way. So it's basically you have to instruct the model to behave based on your norms, and that you cannot predict every single thing, but for the safety things, it's a very much of a human effort than an automated effort.
Okay, just to understand better, this interaction changes the model, underlying model, or only affect how you can use the model?
It only affects the answer that the output you receive. Okay. Yeah. It's
about the idea in case of responsible AI, also with proprietary models on when we control, we would like to control how users interact with our model. Because I was thinking about the jailbreaking. So jailbreaking.
Jailbreaking, yes, of course.
I could interact with ChatGPT and by crafting specific prompts, make the model say whatever I want.
Yeah, it's getting more and more difficult, but yes, you could if you were very good. Yes, absolutely.
So I was just thinking this kind of makes sense also for the open source model, because if the problem is I can't control how users will use my model. This kind of happens also for proprietary models, because at the end also OpenAI does still there is a small possibility where we could have ChatGPT say something harmful, say copyrighted materials, etc. So no, more of the question. But
no. I think that's a very good. Again, here the issue with the open and proprietary becomes the issue of responsibility. Who is responsible if the model says something wrong? And this was also a big point of contention during the AI Act in terms of responsibility of open source developers, because in the original version of the AI Act, they were holding the open source developers responsible if something happened. They removed it now because there was a big backlash saying that you can't hold open source. So, but however, if ChatGPT said something wrong, probably OpenAI would be the one you would sue, like saying that this was harmful. So this is also a big discussion of who is responsible for the output. And you do it as out of your goodwill. You maintain an open source software or an open source AI. But then in the end, if the model doesn't behave the way it should, who's responsible? It's a big ethical question. I don't have an answer for that.
I would propose, is it legal in some sense, is there any regulation? Because you say you can sue ChatGPT if the answer is wrong, but in the end, first of all, like you say, it's very difficult to see what people are really doing. But in the end, it seems that this is going to be just an instrument for doing anything. It's going to be by some sort of law.
Yes, the law would be AI Act. Yeah.
Otherwise, it's like sort of hope
No.
not the best that we can live with, but in the end, it doesn't make any.
Yes, that's absolutely. That's a very good point. It's exactly what AI Act is trying to do, where people demonize it a bit, saying that it's going to stop innovation, but that's exactly what it wants to do. It categorizes the roles of each person, the producers of these models, the users, the deployers. There are different sources, and it's already in vigor since last August, and it will be fully operational next year. So it does give responsibilities for who produces it. For example, ChatGPT, OpenAI would be the one responsible if they can demonstrate harm that has done through this model. So yes, there are regulations. There are also companies like that. They need to demonstrate some kind of a conformity assessment. They need to show that I have tested this model on these safety benchmarks. There are also a lot of ISO standards that are being developed on safety, on responsible usage, and they should be saying that I checked all these boxes, my model is robust, it's safe. And if still something happens, in the end, the responsibility goes to OpenAI. So if it's a commercial model. For an open source model, it depends on who deploys it. So if you are a company and you deploy an open source model, the maintainer of the open source model is not responsible. But you, if you're using that, you would be responsible if somebody uses it for, that would be kind of, it's also subject to interpretation in terms of culpable accountability. But yes, it's really an evolving field. Fascinating to understand who does what in the whole chain.
So thank you very much, Shalini, and thank you for everyone for coming. Okay.
Thank you.